Hi everyone, I'm going to mark the homework for meeting 12. The homework was around Euler's function, which is phi n. You needed to download the questions and answer them. They are these. First, list the steps for finding phi 55. So we know that phi n, when n is a prime number, equals p minus 1 times q minus 1, where p and q are the prime factors of n. So if we prime factorize 55, we get 5 times 11. So 555 equals 5 times 11, which equals 5 minus 1 times 11 minus 1. So 4 times 10, which equals 40. For number 2, it's the same logic. So 551 equals 3 times 17, which equals 3 minus 1, which is 2, times 17 minus 1, which is 16. So 2 times 16 equals 32. For number 3, it is a lot more challenging. It asks, why does phi p times q equals p minus 1 times q minus 1? The answer to this is not that simple. If you search it up online, there is an answer. So it's this equation right here. It is because phi p times q equals phi p times phi q. This is because phi is a multiplicative function, which means that phi a times b equals phi a times phi b. So phi is one of the examples of a multiplicative function. There are other multiplicative functions out there too, such as the greatest common divisor, Mobius function, divisor function, the number of non-isomorphic abelian groups of order n, and a bunch of other functions that I've never heard of and don't know how to pronounce. But phi n is one of the multiplicative functions, so that's why this exists. And this question was really hard to get, so if you didn't get it completely right, it's okay. So that's the answer for number 3. Now let's look at the individual homework. First is Ellie's. For number 1, you said n equals 55, so p equals 11 and q equals 5. That is part of the answer. So you got p and q. You need to continue it. So you need to do p minus 1 times q minus 1 and 4 times 10, which is 40. For number 2, this is the right formula. So you need to plug in the numbers. So it asks for 551, so you do n equals 51, and then p equals 3, q equals 17, which equals 3 times 17, which equals 2 times 16, which equals 32. So I'm not sure why you split it up like this, but you should list all of the steps. For number 3, I don't really understand your explanation. So you can see my explanation at the beginning of the video. It is because phi is a multiplicative function. Next is Gary's. For number 1, you got the answer right, but in here you should add brackets, because if you don't, it would do the multiplication first instead of the subtraction first. Also, here, I'm not sure what happened, but where the phi 7 came from. So 555 equals 5 times phi 11, which equals this. For number 2, the answer is right too, but make sure to add brackets for the subtraction parts. For number 3, this isn't completely right. For example, if you do like 3 is a prime number, if you minus 1, it equals 2, but 2 is also a prime number. So this isn't strictly correct. And the answer is because phi is a multiplicative function, so that's why this formula exists. Or like, because phi is a multiplicative function, phi p times q equals phi p times phi q. And because p and q are prime numbers, we can then turn it into p minus 1 times q minus 1. You can see the explanation at the beginning of the video. Next is Grace's. Number 1 is correct. Number 2 is correct too. For number 3, it's also correct. I think you're the only person who wrote down this word, multiplicative function, and that's the word I'm looking for. So your explanation for number 3 is perfect too. Good job. Next is Henry's. Your code is good, but there is one mistake. Here you forgot to put m equals t. If you don't put it, this loop never stops. For example, when we run this, it never gives us an answer because it never gets out of this loop. But now, if you put the m equals t, we can have an answer. So the code is right now, and this logic is right too. Make sure you also know the answers to the 3 homework questions too, that I explained at the beginning of the video. Next is Jesse's. For number 1 is correct, number 2 is correct. Number 3 is not completely right. Phi n doesn't equal n minus 1 unless n is a prime number. But here n isn't a prime number because it equals p times q, which are the prime factors. So this logic is not right here. The reason for phi p times q equals p minus 1 times q minus 1 is because phi is a multiplicative function. That means phi pq equals phi p times phi q, and because p and q are prime numbers, it equals p minus 1 times q minus 1. You can also see the explanation at the beginning of the video. Next is Mitchell's. Number 1 and number 2 are both correct. For number 3, the second paragraph is correct, but the first paragraph doesn't really have a connection. So yes, phi p times q equals phi p times phi q, but that doesn't mean that phi p equals p minus 1 and phi q equals q minus 1. So all 3 of these equations are correct, but they don't really logically connect together. The reason why this is correct is because phi is a multiplicative function, so you needed to write that. Because phi is a multiplicative function, this works, and then because p and q are prime numbers, these 2 equations work, and then we get this. So yeah. You can also see the explanation at the beginning of the video, but good job on number 1 and number 2. Next is Richard's. You got both number 1 and number 2 right. For number 3, the explanation is a bit too simple. So because they're prime numbers, phi p times q equals phi p times phi q equals p minus 1 times q minus 1. This is correct, but it's not because p and q are prime numbers. It's also because phi is a multiplicative function, which means phi pq equals phi p times phi q. And then because p and q are prime numbers, phi p times phi q equals p minus 1 times q minus 1. So if this were to be correct, it would be like since phi is a multiplicative function, this, and then since p and q are prime numbers, this, and then you connect phi p times q equals p minus 1 times q minus 1. And you can also see the explanation at the beginning of the video. Next is Williams. For number 1 and number 2, they're both right. For number 3, good job! You should watch the beginning of the video to see the explanation. It is because phi is a multiplicative function, so phi pq equals phi p times phi q. And then because p and q are prime numbers, so pi p times phi q equals p minus 1 times q minus 1. Next is Dylan's number 11 homework. So the first one, two non-identical prime numbers. First of all, 8 is not a prime number. So you could say like 7 and 13 or something along those lines. Number 2 is right, number 3 is right, number 4 is right. Number 5, 21 is not a prime number. So the bigger number has to be a prime number for number 5. So you could say 23 and 4. Number 6 is right, number 7 is right. Oh, yeah, so only number 5 and number 1 needs to be corrected. Well done. Next is your homework for number 12. You got number 1 and number 2 right. For number 3, this line is right. This is not right. N is not co-prime to P and Q because P and Q are factors of N, so there is no way they're co-prime. So this equation is right, but it's not because of these factors. It's because phi is a multiplicative function. So you needed to write, because phi is a multiplicative function, this equation is right. And then because p and q are prime numbers, we get phi p times phi q equals p minus 1 times q minus 1. So you needed to explain why this is correct. It's because phi is a multiplicative function. And also, this is not correct. So this doesn't really help with the argument. You can also watch the more detailed explanation at the beginning of the video. That's it for all of the marking. Thank you for watching.